Hello, it's radian time. We've talked about how to convert angles from degrees to radians, but we haven't spent much time finding coterminal angles or reference angles. So that's what we're going to focus on. Same idea as finding coterminal angles with degrees. You take your initial angle and you add one full rotation. Well, one full rotation in radians is 2 pi. So we would add 2 pi instead of 360. And then we could add another 2 pi and another 2 pi. So we can add multiples of 2 pi, or we can subtract 2 pi or subtract another 2 pi, etc., etc. So we add and subtract multiples of 2 pi. So the expression that we can use to do the adding and subtracting is much like what we used for degrees. So instead of 360, we're going to take 2 pi and we're going to multiply that by an integer, n. And we're going to let n be an integer so that if n is positive, we're adding. So if n is 1, we add 2 pi. If n is 2, we add 2 pi twice. If n is 3, etc. Or we can subtract. If n is negative 1, we're subtracting 2 pi. So very similar procedure. We just deal with radians and exact values. Okay, so once again, we are interested in what quadrant does the terminal side lie. Okay, so we're getting more comfortable with angles and radians. And what I always think of is in reference to one full rotation. So one full rotation is 2 pi, which if I'm talking about an angle whose denominator is 3, then I know that one full rotation, or 2 pi radians, is going to be 6 pi over 3. Okay, so 2 is equivalent to 6 over 3. So I know when I have 4 pi over 3, that's less than one full rotation. And if you remember our sector circles from the previous video, we know that pi over 3 is equal to 60 degrees, or it's basically 2 of our 30-degree sectors. So we know that 2 of these sections would represent pi over 3 radians. So we can go around and count off till we get to 4 pi over 3. Or we can look at it in terms of, we know that 1 pi, is equal to 3 pi over 3. Okay, so my 4 pi over 3 is going to be more than pi because 4 is bigger than 3. So I'm at 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3. So the terminal side of my angle would be in quadrant 3. Okay, so this is my angle that's 4 pi over 3. All right, so if I want to find a positive angle or a negative angle or multiple, then all I have to do is add one full rotation because we want the terminal side to end in that same spot. So I can take 4 pi over 3 and I'm going to add 2 pi. So this is just basically fraction work. So 2 pi is equal to 6 pi over 3. So basically, to find the equivalent for 2 pi, you just double the denominator. 3 times 2 is 6. So that's equivalent to 2 pi. So then it's adding fractions. 4/3 plus 6/3 is 10/3. So I have 10/3 pi. So this is the next positive angle that's coterminal. If I wanted another positive angle, then I would add another 6 pi over 3, or 2 pi. Okay, so if I want to find a negative angle coterminal, then I subtract 2 pi, which would be subtracting the equivalent fraction of 6 pi over 3. So 4/3 minus 6/3 is negative 2/3, or negative 2 pi over 3. So that means basically this is what we would call our greatest negative angle that's coterminal, meaning an angle between 0 and negative 2 pi. So that would actually be this distance here, would be negative 2 pi over 3. Okay, so same idea as with degrees, it's just we're working with radians. So if I have negative 7 pi over 4, okay, so where would the terminal side lie? All right, well, I'm starting on the positive x-axis. Now we're doing negative rotations, but we know this is our 8-sector circle, and each sector is divided into 45 degrees, or pi over 4 radians. So that means if I go one sector, I'm going to be going in the negative direction. That's negative pi over 4 radians. Okay, so I need to go 7 of those. Well, I know that 2 pi, if I went one full rotation in the negative direction, it would be 8 pi over 4, because all I have to do is double the denominator. And if I went pi would be 4 pi over 4. So I'm going to 7 sectors in the negative direction. All right, so we can count those off. This is 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. So my terminal side lies in quadrant 1. So this is my angle, negative 7 pi over 4. So terminates in quadrant 1. Okay, so to find coterminal angles, then same idea. If I want a positive angle, I'm going to have to add to get from my negative to my positive. So I'm going to add 2 pi, which is equal to, whoops, I do that all the time, which is equal to 8 pi over 4, double the denominator for 2 pi. So negative 7 fourths plus 8 fourths, or you could just say negative 7 plus 8 is 1 pi over 4, or you could think of that as 1/4 pi if you like that better. Okay, so that would be a coterminal angle. That would actually be our least positive coterminal angle. And if I wanted a negative angle coterminal, then I would subtract 2 pi. Or subtract 8 pi over 4, which would be, so ultimately I have negative 7 minus 8, which is negative 15 pi over 4. So that angle would also have this terminal side in quadrant 1.